Hey guys, welcome back for the CCNA Let's Play episode 3. So, let me get my chair back. Last time, so I record a few episodes in a row. So last time we did copper cabling, we've completed copper cabling. We are at 3% on the CCNA certification, level 3, 2 streak, and we are ranking 138. Okay, so for the one who want to join the community, we have a Discord server. You can join whenever you want. It's, I don't know if I can show you the Discord server. I'll do it right now. Okay, so here it is. We are 150 members. And we can back to it. So, fiber optic cabling. Resume learning. I mute my microphone. So, okay. Fiber optic cabling. Introduction. Fiber optics are used in modern network or high band switch and low latency connection. I don't have a fiber cable with me, but I think it's okay. Fiber optic send information using light pulse, not electrical pulse, signal like copper cabler. These allow for faster data transfer. In this course, we will focus on the two main families of fiber optics. My coffee. So, single mode fiber SMF in yellow and multi-mode fiber MMF in red. So the main difference between these two types lies in the core size, the light source, and the greatest distance. Okay. Now that you know two main families of fiber, let's take a closer look at how fiber optic cable is structured. What do fiber optics use to send information? So light in 5 characters. Fiber optic structure. To begin with, you need to understand that a fiber optic cable is made of several parts. Core, padding, coating. On the outside, there is a coating. This is a protective layer that shields the fiber from shock or humidity. Additional layers such as buffer, strands, rubber, a jacket may also be added for extra protection. Just below it is a cladding. It surrounds the core and plays a crucial role. It gives the light inside the core by reflecting it back through the phenomenon of total internal reflection. Okay. Finally, at the center, we have the core. This is the part where the light actually travels and where information is transmitted. The size of the core changes depending on the type of fiber optic cable. Okay, so OM1, OM2, OS2. Okay, core size comparison. Core 60.5 micrometer, 50. 9 micrometer. It is micrometer, I think. Wait, do not use. Yeah, I'm French. Micrometer. Okay. So, in single mode fiber, OS1, OS2 about 9 micrometer. In multi-mode fiber, OM1, OM2. Okay, so single mode c'est OS, multi-mode is OM. Okay. So single mode fiber always 9 micrometers, and multimode fiber are either 62.5 micrometer or 50 micrometer for OM2, OM3, OM4, OM5. The score size are important and should be memorized for the CCNA exam. Okay, so must be memorized. Single mode fiber 9 micrometer, multi-mode fiber 62.5 or 50 micrometers. From one, those. Single, the littles, okay. The score size, since the size of the core determines the fiber tip, let's now focus on single mode fiber and see how it works. Which fiber has a very small core? Single mode. Oh. Okay, that is correct. Single mode fiber. In single mode fiber, light transmission is achieved using a laser. Device is expensive but very precise. The light travels in a straight line through the fiber core. Okay, so laser, single mode fiber, very precise but very expensive. Okay, that's right. In a straight line through the fiber cores, which make it possible to carry information across very long distance. Light in a single mode fiber experiences minimal loss and almost no dispersion. Ethernet standard to know. For the CCNA exam, you should be able to identify common single mode fiber mode Ethernet standard. Okay, 1000 bars ALX, 1 gigabyte per second, long wavelengths. Okay, so likes, long wavelengths. Focal range 5 to 10 km. 10 gigabits per hour. Okay, around 10 km. Like XLR, always refer to single mode fiber. Okay, single mode is great for long distance, as you can see, but what about shorter distance and cost-effective links? That's where multi-mode fiber comes in. Which light source the single mode fiber use? Laser, I think. Okay, level 4, yeah, okay. Multi-mode fiber. Yes, multi-mode fiber works differently from single mode. Here the core is much larger, 50 or 62.5 micrometer, and allows several light rays to propagate in parallel. Okay, so several light in parallel. The light source is usually a LED, light emitting diode, or a VC cell, vertical cavity surface emitting laser. Oh, okay. These components are less expensive than laser but are less precise. Because multi-light rays bounce inside the core and follow different paths, dispersion occurs. This limits the range significantly, usually to a few hundred meters. Okay, so single mode fiber is 5 to 10 kilometers, and multi-mode fiber reflects multiple light rays, so 100 meters. Okay. Ethernet standard to know. Again, for CCNA, you should be able to identify common multipod Ethernet standards. 1000 base A6 and each gigabase SR. 220 meter for OM1 to 5 meters for OM2. 200 for OM3, 100 for OM4. Okay, OM3, 100, OM4, 400. I think you just have to know this. Okay. make it easier to distinguish them in practice, fibers also come with different jacket colors. So which light source is called? Multi-light fiber, LED. We seen it just before, that is correct. Fiber colors are different, so single mode yellow, multi-mode typically orange or aqua. Okay, small core, use a laser, support long distance, more expensive. Larger core, use a LED or VCSL, fit for shorter distance and less expensive. It's also important to understand how fiber links actually transmit and receive data. Single is yellow. Okay. P-ax and R-ax in fiber links. Oh, okay. It becomes technical. Quite visual. Fiber optic cabling is used in pair of stands. One stand is used as transmit, send information, and the other stand is used for receive information. This design allows fiber optics to operate in full duplex mode. Okay, so the duplex is the way the data come. So full duplex, you can send and receive at the same time. In the diagram above, you can see two interfaces connected with fiber optics, for example, between two routers. Okay, so one interface, another interface, SFP, transmit, receive. Simple. On the left side, gray, there is an SFP. This is a compact, hot, swappable transceiver. Its job is to change the router electrical signal into light. So TX stand, then it converts the light received on the RX stand back into electrical signal. Okay, so white here, electrical, light pulse to electrical. Well, the sides are always cross-connected. The TX on one side is connected to the AWACS on another. So this way, one strand sends data while the other receives it. Okay, here the two fiber interfaces are communicating with each other. If the fiber are reverses, the link will not work. In a real scenario, imagine router around building A and router 2 in building B. Single mode fiber will be used to connect these two devices over long distance. Oh, start Sally. Now that you've seen how a fiber optic connection works, let's verify this link from the router point of view. Okay, so enable and show interface gigabit. Oula, gigabyte, internet, 0, gigabit, interface 00 is up, line protocol is up, connected, output omitted for T. Okay. This confirms that fiber link detected on router 1. Okay, so we are in router 1. Up, protocol is up. X and X correctly connected between R1 and R2. The fiber interface is operational. Send, transmit, so T. Conclusion. Wrap up is a single mode plus multi-mode variable. Need to know. Okay, so tell the error. Not. Schedule core size. So single mode 9 micrometer, multi-mode 62.5 micrometer and 50 micrometers. Laser LED, yellow, orange, aqua, up to 100 kilometers, 510 for LXLR, a few hundred meters. Okay, Leçon completed. 7 tasks. Demonstrate your expertise and showcase your progress. Okay. Return to dashboard. Yeah, I will return to dashboard. 3%. Doreen, let's. I think I'm mistaken last time. I will change right away. Okay. What's my ranking, guys? 108. What a monster. 10,000 XP in the month. So each month the XP reset, not your global XP. So for example, Elvin has 4,000 XP, but in this month only 3,000 because it's a monthly ranking challenge. So 10,000 XP in 20 days is just what the fuck? Okay. So, I think it's a battle of the year. Okay, so guys, we finished the fiber optic cabling. And what time I'm okay. Well, we will do the what is network model last time. Okay, so I have to buy the premium access. I will do it next time. And okay, so bye guys, and see you soon for the fourth episode. Bye bye.